Yeah, hi, good evening, everyone. So,
Good evening, sir.
so last week actually we couldn't complete this practice assignments of week 9. So today we will cover this practice programming assignment and theory assignments. Okay, and the coming Friday we will start the week 10 content. Okay, so meanwhile you can just watch the videos of the week 10. The syllabus of the OPP 2 actually is till week 10. So complete all the questions, assignment question, programming questions till week 10. Okay, so then you can solve the problems of the OPP2. Okay, so any query before starting the session? Have you tried the assignments questions of week 9? Have you completed any specific query? Oh,
No, sir.
okay. Then we will discuss all the PPAs of the week 9. So you can also solve the GRP. I think GRP's last date is tomorrow. So let's share my screen. Okay. So week 9 is basically we have discussed the concept that structure and that enum or not structure, the dynamic memory and two-dimensional array. Structure was actually week 8. Okay, so week 9 we are learning dynamic memory allocation and two-dimensional array. So the questions are also based on this. One question I have discussed in the last Tuesday, that summary session, link list based question. Okay, so how we can link the element in a by the address, and later we can use all the data because that are linked by the address. Okay, so that concept we will use in this PPA question first. So that is also we can solve by the linked list concept. So this PPA first is actually some create employee list using dynamic memory allocation. Here one we need to complete the function. So this employee list, the function name, and inside this, if you see the sample input, what is given? Some one name is given employee one. Okay, so this is actually representing the name of employee. So this is just dummy data, and after one space, the salary of the employee is given, and next value is just a 1 or 0. That is representing that if user press this 1, that means the user will input one more data to the program. At any time if user print any value apart from this 1, so at that time our output should become. So here what is the main goal in this program is, so read the employee's name and salary separated by space and add structure to the list. And okay, so this is the things we need to read this data from the user. And also if user is pressing 1, then we again will read one employee data. In this manner we will store our all employees data in some data structure. And after that what we will do, so next second point is read choice as integer. If the input is 1, go to step 1 again to read the next employee data. And if the input is 0, then stop and print all employee names that have a maximum salary, each in a new line. Okay, so in the sample input you can see we have total 5 employee details, and among these 5 employee details you can see which what is the maximum salary. So maximum salary is 20,000. So how many employee contain that maximum salary? 3 employees, employee 1 and employee 3 and employee 4. So that name should be printed in the output in the similar same order in which the employee which is inserted in the data structure. So employee 1 inserted first in our record, then employee 3 inserted later, then employee 4 inserted after 3. So order should remain the same in the output. Okay, so this is our task here, and some part of the code is already given. So you can see. So you can see some code is already given. So that is a header file. After that, one structure is given. So structure is already given in the program. So what structure contains? The name of the structure is employee. Okay, and inside this structure we are maintaining three variables. So three variables is name, that means employee name, that the maximum length of the name will be 50 characters, and salary, and one pointer is also mentioned. So this is given because we can just link each employee to the next employee in our record. And after that, this void employee list, we need to create this, complete this function. And this is the main function given below, where we are calling this function directly without doing anything. So int main and calling this function. So we need to complete this employee list function to get our output. So this is so I've already explained the concept of this linked list. Let me just define again for some basic idea. So we will maintain one head. Okay, so one head pointer. Okay, so this is just a pointer, and that will only contain the address of the first employee record. Okay, and each employee record will contain, so this block is actually representing a one structure which is given in the code, employee. Okay, so first field is actually containing the name of employee, and second field is containing the salary, and third contain is a pointer, and that will contain the address of the another similar type of block. Okay, that will also contain the three information: name, salary, and pointer. Okay, so this structure allocation we will perform on the runtime, so that we will use the dynamic memory allocation for this structure. And we will allocate the memory using this malloc and calloc function, which we used for the dynamic memory allocation. And we will link in this manner. So first time we will link the first employee detail with the head. After that, second employee detail address we will store inside the first employee pointer field, and the third, like in the similar way, third employee detail we will store, and we will store the address of third employee block inside the second employee block last field, pointer field. Okay, here. So in this manner all data will be linked. Okay, so after doing this, and at the same time we will also compare the salary, and we will find out the maximum salary. And after this, after getting the maximum salary, we will run one iteration again on this list from the starting, and we will check which employee contain the same maximum salary, and then we will print the name of the employee in the same order. Okay, so this is the basic idea of this program. So let's write the code for this. Okay, so first thing, inside the employee list, we will create a, so first thing is maximum salary. We need to find out the maximum salary also. So we will just write a one variable for the maximum salary. Okay, max sal. So I'm just defining this. Okay, in max cell. After that, we will, so our structure name is employee. So we have to create some pointer to like this head thing. Okay, so head thing, we are using this head, first head for the first employee detail. Similar way, we can also maintain the last. Okay, last field. Otherwise we have to run one while loop to reach at the last point. Okay, so that things we have already discussed in the previous Tuesday. If you don't, if you have skipped that, just watch again in the detail. So for, we will create some pointer of this struct type. So like struct, we will name the name struct, and our structure name is employee. So employee. Okay, and we will just create, so like head. Okay, one is head, and initially we will assign by the null value. Okay, because initially no data is inserted in our list, so this is initialized by the null. After that, we will use one temp variable also. So just to traverse, or we can use some place so that we can assign, like this is also to find. And similarly, last we can also maintain. So asterisk last. So last is for to store the address of the last element in our list. So we can directly insert the element at the last position without traversing from the first. So this is null. So we will initialize later if any other variable is required. Okay. So right now this is coming in my mind. So after that, what we will do? So actually in the input, user is just giving choice. Okay, so based on the one value or zero value. So if user is giving choice one, then that means user want to insert one more data. Okay, and if user is pressing zero, that means we user not want to don't want to insert more data. At that time we will stop the process. So we will create one more variable. So int choice. Okay, int choice. Now, because this is continuous loop, we don't know how many inputs user will provide us. So we will use the do while loop here. Okay, so do, and similar manner we will use the while. So to complete this while. So this is the structure of the do while. Okay, so do, and we will write the statement inside the do, and after that we will check the while condition. If while condition is true, then this do part will execute again. So in this manner, we will create our code. So inside this do, because when we are entering inside the do, that means we want to read one data from the user, and we will insert that data in our list or record. So we will create memory allocation here. So we will take like this struct employee. Okay, and like this is just a, this is the same variable we have created as, okay, and we will allocate the memory for this. So the memory will type is also same. So struct employee same, we will write, this is for the typecast, because malloc function return a void pointer. So we will convert that pointer into a struct type, and after that malloc, and we will provide the size of our structure, size of, because we don't know how much size our structure will take, so we will use this function directly. So size of our structure. Okay, so in this manner, one block, memory block, will be created for the one employee details. So that will contain actually three fields: name, salary, and pointer. So that memory will be allocated to this as pointer. Okay, so this as pointer will contain a address of the new pointer, new block, and we will add this block into our list. So how we will do? First, we will check this block is a first block or not. Okay, because if this is a first block, that means we will add. We will consider this as a head. Okay, this is the start point of the record. So we will check if head equal to null. Okay, if this condition is true, that means okay, if this condition is true, that means our head is now not initialized by any element. So that means our list is empty. So in this case, we will just make this first block as a head first element in our list. So we can simply write like this: head equal to this s. Okay, this is the simple statement, and also we will, because this is the only first element, and this will also be the last element. So we will also mention this last equal to s. One more thing we can do, because every time we will insert this data at the last, so there is one field point that okay, this next field. Okay, so inside the structure, this there is one next field. We can directly fill this field by the null value. Okay, So that okay, that null structure, yeah, that we can fill by the null value, because this every no block will be insert at the last. So s, and this is a pointer, so we can use this parameter and we can write like struct employee next. Okay, so asterisk next, not asterisk, sorry, only next equal to null. So this is the common, because last node not contain any address of the next node, because that is the last node. So because of that we are filling by that field by the null. Okay, if any node is coming after that we will update. So this is the first condition if we are adding the node at first time. Otherwise, else part, we will simply add the element after last element. So what we will do, we will just mention the last dot next equal to s, and last equal to s. Okay, so in this manner our elements will add into our list. So this part is now done. So this do will run. After doing this, so let me just verify that it's in that part brackets. Okay, so this ending is here, this ending is here, this is here, so I think this is extra. Okay, so this part is done. Now, yeah, after this, okay, so the employee field is now required. So we will need two values from the input. That value is actually uh, name of the employee and salary of the employee. So here we will use two scanf field. So scanf and percentile. So first value is name, so that is s, space, that another value is that percentile salary, so that t, and we will write this like s. So this is the name field, so name comma, and salary field is there, so we will add the end symbol, so s salary. Okay, so name and salary. So this two value we are reading, and the one more value we will read for the next line, that is choice. So that means we will ask to the user if he want to insert one more data or not. So scanf, that is actually choice, percentile d, and symbol choice. And every time when we are inserting each record, at that time we will also compare the salary. Okay, so initially we have initialized max salary. Okay, so we can also initialize by 0, and after that we simply compare this like if max sal is greater than not max sal, actually this s salary, s dot sal is greater than max sal, then we will update this by the new big value. So that means max sal equal to s dash sal. Okay. So in the by this condition, every time we will compare our salary to the previous maximum salary, and if we are getting greater salary, then we will update. So this is the part. Okay, so this is the done. Now in while condition, we will check while if choice equal to one, h choice equal to one. So that means this two while loop will repeat if choice equal to one. Otherwise, this will terminate. If our choice value is not one, then this loop will terminate. So this is the part when we are inserting our record in our data structure. After that, we have already find out the maximum salary in this process. Now our final task is just to print the name of employee, those who have maximum salary. So that is the part which we will write after this while condition. So for this while condition, we will start with the same. We will so I have temp. Okay, so we will use this temp variable here. So I just initialize this temp by head. Okay, head is the first element of the list, and we will run one while loop. So while our head is not sorry, our temp is not equal to null. Okay, so that means we are starting from the first element, temp equal to head. Head means first element, and we will repeat this while loop until our temp does not become that null. Okay, so what we will do in this process? So every time we will just compare the maximum salary with the current node salary. If it is equal, then we will print, and then we will move our temp to the next record, next employee detail. Okay, so in this manner we will simply write the condition if max cell equal to current node salary. Okay, so temp dot salary. Okay, if this condition is true, then we will print. So printf that, and what we will print? We will print the employee name. So that means temp equal to, sorry, this is percentile s, and after this temp equal to salary. Okay, now this is done, and after out of this we will move our temp equal to next element. So temp equal to temp dot next, not dot temp dot next. Yeah, so this loop is actually print the salary of each employee, those who have the maximum salary. So now this program contains two parts. First we are reading the data, okay, and getting the maximum salary. After that we are comparing the salary with the maximum salary. If that is equal, then we will print. Okay, so let's check this. Maybe some error we will get. Let's quickly check. Okay, we are getting some error. So unexpected. Okay, so we have missed some colon someplace. Yeah, this is last. Okay, let's run again. Still we're getting next undeclare first is the function did mean exit temp dot salary 8%. Oh, temp dot salary. So inside the print statement. Oh, this is name actually. The choice. I'll go in the format scanf percentile d. Oh, that is choice. Where is choice? Yeah. Okay, so let's error next and declare first using this function that you mean exit last. Okay, last next. Yes. Okay, so still we are not get okay. So that new line, okay, things. So we missed this new line character in the print statement, and inside this print slash. Okay, now we are getting the correct answer, you can see. So this last lesson actually not affect the matching. So if we are getting this, so now both are matched. But this space or extra new line character should not be come in between the strings. Okay, like employee one, if you mention one space inside this employee one, then it will not matched. So now our output is correct. So any query in this code, any part, if it's not clear? Any query? Is it clear? If you have any doubt in any part of this code, please just ask. Okay, so because these are important topics for the OPP2. Can anyone respond? Is it clear? Can we move to the next?
Yes, sir.
Okay. Okay, so this is two-dimensional array-based question. So write a function in two-dim array which takes two integer as input row and column and call and returns a double pointer. The function declares a double pointer and dynamically allocate memory for two-dimensional integer array of size row into column. The function then initialize all the elements of two-dimensional array to 0. So this means we are creating a two-dimensional array but using the pointer. Okay, not direct that in that array things. Okay, we can also create a two-dimensional array by just array name, and we can pass the 2D to okay size in two brackets that will represent row and column. But here we are just initializing and we are creating this array using the dynamic memory allocation. Okay, and we will use the pointer for this. So our function is actually taking row and column uh, size of the array, and after that we will create this two-dimensional array using the pointer or dynamic memory allocation. So here example is given. So this row, two rows and two columns, and we are creating this two-dimensional array, and that all place are actually filled by this 0 element. Okay, the size of the row and column won't exceed 10. So size of row and column will not be exceed the 10. What is given? Some code is given, like this suffix code is also given here. So this main function is given. Inside the main function, you can see we are calling this function, and we are getting this pointer, double pointer. Okay, so that is pointer of pointer. And after reading this pointer, we are traversing our array by this pointer name. So this is actually a array now. So p and by this pointer arithmetic, we are just traversing all the elements of the array. So that should be print in the same manner. So you can see we are using nested loop, one for the row, second for the column, and after that we are printing the elements. So that all should be printed as a 0. Okay. So this is the part given in the code, and you need to complete this function which is given in the template. So structure is also given. You need to write the code only the inner part. Okay, you have two parameter row and column. So how we can create a two-dimensional array using the dynamic memory allocation? So what we will do, we will just use two point that variable I and j. So int I comma j, that we will use for the rows and row and column. Okay, so for the two loop, and after that So what we are doing actually, so for you, we know that how many row we have. So like suppose r row equal to, suppose this is given 3 and columns are given like 4. Okay, so that means we have 3 rows and 4 columns. So 3 rows means like this. We will allocate, sorry, not this. Okay. So 3 row. Okay, so we will create a pointer and that memory block. Okay, so this is actually a block for the 4 element, because we have 4 columns. So 4 columns means we can contain 4 integer element inside this block. So that means this should be divided into 4 part. And 4 integer means, so each integer contains 4 byte, so 4 integer means 16 byte. That means this complete block is actually a one block of size 16 byte, and we can store 4 integer elements inside this because our column value is 4. So that part of the memory we will create using the malloc function, and we will store the pointer for this. So this, suppose this is a pointer for row, and this is the first pointer, row 1, and another pointer is like row 2. Okay, this is the pointer of the second block, and this is the pointer for third block, like this. Okay, now we have 3 pointers separately, so we will also create a one array for this. Okay, so that means we will again one create a memory block for this, and that memory block will contain a 3 elements, and each element is a pointer actually. Okay, and that pointer is pointing to a one 4 that 4 columns elements. Okay, so that is 4 integer elements which is represented by the columns, so of the first element. So this actually, this block is a block of the rows pointer. Okay, so that block will contain the pointers for the rows, and these blocks will contain the actual elements. Okay, four elements. So that means four element inside the first blocks, 4 element inside the second, 4 element inside the third block. So total 12 elements will be stored inside this. But overall, we will store the address of this array, only this first array. So this array is actually a array of the pointers, and because of that we are saying that we are using double pointer here. So that array is actually each element is a pointer, and we will store the address of this pointer array. So that will become a double array, double pointer. So in this manner we will create this two-dimensional array. So in this, after the, okay, so first array, first block we will create for the rows pointer. Okay, and each pointer will point to the one column block. So how we can create? So like int asterisk asterisk. So like we can give the name for this as a arr array equal to, and we will use the typecast for this. So same int asterisk asterisk and malloc. Okay, and inside this how many rows we have? We have this number of row, that is actually containing the number of rows. So we will pass this value as a row into, and each element inside this block will contain a pointer of the one another block. So that means we will pass this here like size of an integer pointer. Okay, so that means we will contain the address of the field that contains the integer element. So that means integer pointer. So int asterisk. So that is actually size of 8 byte. Okay, pointer takes 8 byte. So now this will create one array that will contain that number of rows element. Okay, so if row value is 3, so that means that this will contain 3 value, and each value is a pointer. Now this is the first part, and after that we will run a loop for the each row, and for I equal to 0. Okay, and I is less than ROW and I plus plus. Okay, and inside this, for each
Sir, you
row,
left semicolon, sir.
where, okay, this, okay, thanks. So inside this, we will create a block for the columns. So that meant for each ARRI. So this is actually a pointer. Okay, so ARRI, this is representing a pointer field, and we will assign. We will use the same malloc function. So int asterisk, it's a typecast, and malloc, and this time we will creating a block for the integer elements, not the pointer, because these columns actually contain the exact integer element. So that means how many elements? Col into size of int. Okay, now this is created. So okay, this is done. After that, we need to initialize all the fields by the 0 value. So we will use one loop, so that nested loop for the array. So for I equal to 0, I is less than ROW and I plus plus, and inside this loop, we will run one another loop for the column. So for j equal to 0 and j is less than COL and j plus plus. Now you can directly use like an array. So for each element, so ARRI, this is I, and second for the row, and initialize with 0. Okay, so this is the initialization with 0 part, and after that return this array. Okay, so this double pointer ARR actually return from this function. So return ARR. Okay, now this array will be passed in our main function. So you can see that address will become inside this P, and inside this P we can directly print the element. Here we are printing using this arithmetic, or you can also print by this simple indexing. Okay, so this is the solution code. Let's check this. Okay, now this is correct. You can see we are getting the correct output. So all 000 value we are getting correct place. Okay, so any query in this, any part of the, any doubt in this, any part of the code, this solution? No query?
No, sir.
Okay, then move to the third problem. Okay, that is fine. So PP3. So write a function named print transpose that takes 3 input 2D array of the integer, number of rows, number of columns. The function display the transpose of the 2D array given as the parameter. The function doesn't return anything. Okay, so function not return anything. It prints the element. Okay, actually. So this is a given array. So that the number of rows is 2, number of column is 1. So 3 and 4. Okay, and this will be transport, so it will become a rows. So here this is given as a first row, second row. Now this will become a only one row, but with one column, two column, 3 4 like this. So you need to print as a transpose of the given array. So here you can see inside the main function, maximum size of the input is 10, and R and C is initialized, so that this part is actually is creating a array A. After that, this function is called, from the main function. First value is array, and this is the number of rows, number of columns, and your function should print the transpose of the input array. So you can see like how elements are printing. Okay, so all elements are coming in this rows, but here all elements are printed as a column wise. Okay, so this is simple transpose based function. So what you can do, you can simply create a new array, and that you can store the elements in the transpose form, and then after that you can traverse that array and print the elements simple. So that you can also do, or you can also print the element directly. Just traverse the row wise, and in this the same manner you can print in the transpose form. So let's do the code for this. So void, because function does not return anything, so we are using this void, and function name is print transpose. Okay, and it is taking three parameters. So first parameter is basically a, we will pass this size 10, 10, because this is the maximum size, and int r, okay, and int c. Okay, so this is the definition function name. After that, we will create one new array. So like int t, for transport t, and size is 10 and
So
10.
why can't we do transpose directly, sir?
How you can also do, you can traverse column wise data, and you can print row like that. You can also do. Otherwise, you can create a new transpose matrix, and then you can print also. That is helpful, because if sometimes that suppose if any problem statement asks to return the transpose matrix, okay, so that is the same
Okay, sir.
process you can directly do also. So, so this is just extra steps I'm writing here. So this is new array of the same size, but we will use the number of row and column as per given R and C. So same for loop for I. Okay, so I is start with 0 and I is less than R. What is this? So I plus plus, and inside this for j equal to 0 and j less than c, and j plus plus. Inside this we will use this t array, and we will just pass the I and j in the reverse. Okay, so here j first and that r first, sorry, I in the second, and we will assign the element of this a in the reverse manner. So like a I here, but j as a second element. This is the simple steps to read the element in the transpose form. So here first, this indexing we are actually using for the rows, and second indexing we are using for the columns. But during the filling of the inside the transpose matrix, we are using this j as a rows and I as a columns. Okay, but we are reading the elements from the input array in the same manner. So I as a row and j as column. So after that, this is now creating a new matrix, that is transpose matrix, and after that you can print the element of the new matrix in the by the simple same loop, and you can use the same iteration, but this time print a statement. Enter D, and here this T, okay, and I comma J. So elements should be print space separated, and also new line character is also there after the one row printing. So we can use the new line character print statement. So only slash n without any element. All the pattern. Okay, so let's run this. We're getting some error. No,
So we didn't give int a of 10 of 10.
so function main warning implicit declaration of the print transpose ARC.
Array type we didn't give.
Sorry, what?
Array type we didn't give, sir. Int a of 10 of 10.
Okay, okay, that type. Yeah. Okay. Thanks. Okay, still loop. Yeah, first is in the for I j is less than c j plus plus. Okay, so that is I undeclared and there is j undeclared. So okay, so I'm using this directly. So what difference we are getting? So over here this 8 is coming. 2 8. Okay, the int is R and C. So R we are reading, J we are reading. And 3. So here this is correct, but 2 and 3 this should become correctly, but this is 8. So T 10 10. So I 0 is less than R, I plus plus J is 0, J less than C, C J plus plus J I J. Oops, let's see when. Why the output is not correct? Wait. In RNC, that is function set A R and C A I R. Okay, okay. Yeah, actually, our size is now become different because now in the new transpose list, now R become a columns and C become a rows. So that
Yes,
we
sir.
have
Actually, in the sample inputs test cases, it's given interchange.
one second, R. Sample input. What is the mistake? No, actually, what happening because we are creating is the transpose matrix T. So now the value of R actually is representing a columns in our transpose matrix, and C become a number of rows. So we have to use in the same way at the time of printing. Let's check. Now it is correct because in the last code we are using the same rows and same columns, but when we are just making is a transport, so size now become change. So here we have to use the C for the rows and R for the columns value. Oh, this is correct. Okay, so this is the solution for PP3. Any query, if anyone? Okay, then PPA4. So this is step given a null terminated string slice and string using three parameters start and care and step. Okay, strings is given, indexing is starting with 0, negative value start indicate. Okay, negative indexing is also given, negative value for step is representing the reverse order. Line output. Okay. So for this code, I think this some error is there inside this. So that means first value is representing the start index. Okay, so in the sample list, if you count the index, so this H is representing the 0, then E1, then 2, then 3, then 4. Okay, then this comma is 5 index, and one space is 6, and this is representing the 7 index. So that means our output should be start from the 7 index. So this first value is representing the start index. After that, how many characters we need to read? So here the output is actually given 3, but here this value is given 2. So this is not correct. If you look the sample test case, so that is correct, public test case. So here you can see we will start from the second index. So second stat index is representing this L, first L. After that we will read 5 character. Okay, and that should be continuous. After one continuously one, we will add the one value in the index and then we will read the character. So all characters are coming, all 5 characters are coming actually. But in the sample actually this value is representing steps. So after reading the first index, we will add this value to the read the next character. So that means 7 plus 2 will become 9 index. That the second character should be present at the 9 index. This is R. Okay, then we again add 2, then it will become a 9 plus 2 11th index. So that is now D. So this value should be actually 3 in the input in the sample. All public and private test cases are correct, only this problem statements mistake is there. So just consider as a 3. The problem statement is simple. One string is given, you need to print the character in this manner, starting with the first index, and after that, after each so that step value is actually just what way we need to print read the element, how many steps are required. Okay, so in this manner we will just complete this. Okay, so some part is given. So main function, inside this we are reading input string start. Okay, so 3 characters you can see, this is the parameter of the function start and char. So this is second value is representing the number of characters, and this is step, and we are reading the strings and all 3 values in the input. After that we are calling this function, and that function is returning a pointer. So that that is pointer for the strings, and that strings we are printing directly in our main function. So our function should return a pointer of a string. Okay, and that after that we are also freeing this sliced pointer field. Okay, and that will be happen by the dynamic memory allocation. So that means we will create a memory allocation for the sliced using dynamic memory allocation. Okay, so this is slicing coding function. So this function we need to complete. Function declaration is given, and we need to complete this function. So what we will do, we will just create a, so what is the length of the strings, how we can calculate this. Okay, so that's directly function we can use, like int len equal to str len. So this function we have in the strings header, string header, and we can directly pass the input string inside this, so we will get the length of the strings by this function. So this is fine. Okay. Okay, so this function also contains the negative indexing. For negative indexing means, let's take some example. So like hello, LO. So this is representing a 0, 1, 2, 3, 4. So this is the positive indexing, which start with the 0, and negative indexing basically start with the -1 from the end. Okay, so this is -1, -2, -3, -4, -5. Okay, so that is actually used in the Python language. We can directly use this type of indexing, but here this is also given in the problem statement. So suppose start index is given as a negative, like start value. So start is given as a positive, that is fine. Okay, so like 2, so that means 2 index is pointing to this value. Okay, and we will start reading from this. But if start is given like negative indexing, so like -3, so -3 is representing this pointer, okay, from the last. So that means our output should traverse in this from this pointer. So how we can just use this formula? So how we can fix this start value actually? So we can check this if start is less than 0. If start is positive, no problem. If start is less than 0, then we can directly change this start value to start equal to length of the string and plus that what is the value of start. Okay, so start value. Suppose this is -3. So what is the length of this string is 5. Total 5 characters we have. So 5 plus -3. So this will become a positive start. Okay, so this is representing. So actually we are getting negative indexing. So and we are finding out the corresponding positive indexing. So we can use this formula, length plus start. Okay, so length plus negative indexing, and then we will get the positive indexing corresponding. So after that we will write the code in the same manner. So this is the first thing. So we can write the code for this. So if start is less than 0, then use this start equal to length plus start. Okay, so this is the first thing. After that, so how many characters actually we will print? So that is given as a nchar. Okay, so how many characters we need to print? So that is nchar. But actually we are creating one string. We are creating one string. So there is one more characters we have also add in our memory block, that is for the terminator. Okay, so that is null pointer, we can see that, and that is also called as a terminator symbol. So we will just create a memory allocation for this using the malloc function, and we will read the address inside the our return strings pointer. So char, so character pointer like slice equal to, and we will pass the typecast, so same char asterisk and malloc, and inside this malloc size is given already, so nchar, because here character size is only 1. Okay, so each character takes 1 byte, so we can directly pass this nchar, not n_char plus 1. This plus 1 is for terminate symbol, that null pointer, not null pointer, sorry, terminate symbol. So that is not fine. Okay, so after this we will traverse our original input strings in this manner. So start index, then how many characters we have, and then what is the steps required to traverse. So in this manner we will use this for loop. So for starting index, our index will start int I equal to start. Okay, that we have already calculated, and this will run. So I will run till len. Okay, len of the strings. And another possible condition is sometimes if len. Okay, okay, yeah, our there is a chance if we are traversing the list into the reverse manner, so that another condition we will also maintain, so that our end I should greater than or equal to the 0 if we are traversing from the right to left. And this is I plus plus, not plus, I equal to I plus step, because step is given. So every time we will increment our I by step value. Okay, so that is given in the input parameter, this is step value. And in this manner, we will create our output return list. So this every time we will insert our character inside the slice, this new array pointer. So that I is actually a input of I. Okay, and this is done. And so at every time, so this is the one part. And then what is given? J is less than end care is done. Okay, okay, so that one thing is also missed, that we need to traverse only end care. So int j equal to 0, and one more condition we have to maintain here, and j is less than our end care size. CHR. And every time we will increment our j. So what happening actually inside this, we are traversing the list. Suppose if our start is given like 0 and step value is given 2 and end care suppose is given 2. Okay, so this parameters are given and string is given like this hello. So we are traversing this hello by the for loop, so by the I iteration, so we are traversing from the 0 till the last. And every time we will also check our condition, so we need to only traverse 2 characters, okay, not more than that. So we will start from this, so that means this h should be come after 2 steps, so 0 plus 2, so that means this l should be come. Now we have traversed 2 characters, so we will stop our process. Otherwise after this l, our o should also be print if we are not using this n character limit. Okay, so because we need to traverse only 2 characters, so we will start from 0, but after that we will traverse only second character and then we will stop this process. So because of that we are taking this condition, that j condition, so that should also be less than. So we are maintaining this j equal to 0 for this first character, then it will be incremented, so j become 1. And because of that we are taking this condition inside the end, j should be less than to end care, so end care is not 2. Okay, so when this condition become false, our loop will terminate. Okay, so in this manner, now we are traversing. So I think code is done. So yeah, we will return. So this is actually a pointer function. So we will return our text return slice. I think we will list one more thing. Checks first. Did you mean end case? Okay, end case. Cares. And cares. Or one more things, we have also used this terminate condition also. So okay, so slice. So after last j value, actually we have to add this terminate point, terminate symbol, so that j equal to slash 0. This 0. Okay, that is null terminate. Okay, missed. Okay, so we are not getting correct. What happened? Okay, so that we have to use J here. Okay. Yeah, because we will fill this slice by this J index. Okay, this is 0. Then next iteration it will become 1. So that means all indexing should be continuous in this our output strings. So we have replaced this by J, and in this manner we are getting the correct output. Okay. So the slicing things is actually used in the Python very commonly. So how we can read the elements after some steps. Okay, maybe after the interval of 2 or 3 in this manners. So that the similar type of things actually we are trying with the C code. So how we can do the same things in the C by the logic. So that slicing actually we are using here. In Python we can directly use that functions are there. Okay, any query in any part of the code in the solution? Okay, yeah. Generating a range of integer. Design a C program that reads 3 integers from the user's start, end, and step. The program should dynamically generate an array containing a range of integers from start to end with the specified step size. So this is also a very similar to the previous one. Okay, so here also given this start value, end value, and step value. Okay, so you can see the input. So 1 and 10. This is the range given, and interval step value is given 2. So that means we will start from the 1 value, and after interval of 2 we will print all the value. Okay, so that means after 1, then plus 2 is 3, 3 plus 2 is 5, plus 2 7, then plus 2 9. So that all values are coming in this output. So so program will generate a new array of these elements with the step of 2. So I think this is very similar. You need to create a one array. Okay, and after that just create this type of range. So start and end point is given and step value is given. So just create a array dynamically and add all these range into the array, and that return the, I think, function is required to return. Okay, this type structure is given. So start int values and length. So function declaration is already given. Okay. Print array. So that function is totally separate given. Okay. And inside this function, array r, get range steps, print array. Values and length. Okay. So here one structure is given. So structure inside the structure, one pointer field values are given and length are given. So and this pointer val field is actually pointing a array that contains all the range elements. One array. Okay, and this int len is actually maintain the length of the that array. So function is also returning the same data type, that array, that means struct data type, and that will return a structure. And inside this, you need to allocate the same memory allocation by the malloc function. So how you can do this? Okay. So first things we have to find out that how many elements are possible. So if and start point is given, end point is given, and step value is given. So how we can calculate the total number of element in our array possible. So let's take some example, and then we will try to find out the formula for this. So suppose start point is given like 1, end point is given like 10. Okay, and step value is also given 2. So can we calculate the length of the final array? Because in our length, you can simply calculate how many elements will come in this array. So 1, 3, 5, 7, 9. Okay. So this is the 5 elements length should be 5 of our final array. So how we can get the size initially without doing in the by the code. So can we calculate this length? So here one formula we can directly use. So end minus start and divided by the step and plus 1. So like this formula we can directly use to calculate this. So is here end is 10, 10 minus start is 1, and after that step is 2. Okay, and then plus 1. So you can see 9 integer 2 and plus 1, and here we are getting, so this is integer operation, so it will not return the float value, it will only return 4, and plus 1 equal to 5. Okay, so we can get the size of our output list by this formula. So these and start step value is already given in the as a parameter, and we can directly calculate the total size of our list or list, sorry, array by this formula, end minus start divided by step. And after that we can write the code for this. What we can do, we will create the length, so int equal to same formula, so like this, int minus start, okay, divide by step, and add 1 all the complete value plus 1. Okay, so now this is done, and now we will allocate the memory for this. Memory, okay. So because our return type is array structure, so we will create the same return type. So add array like r equal to, okay, so type cast is array malloc, and here pointer array, okay, type cast is array. No, not this. Okay, so we are creating an integer array. So this integer array, let's say, let's take total elements are len, and we will create the len into size of int. Okay, now this is the memory allocation for this. Okay, so this is now initialization. After that we will fill this by the range that values. Okay, so we will use our loop. So for I equal to 0 to start, so that is start point J equal to okay. Okay, indexing we have to use the same way, j equal to 0, because we are filling, we are just getting the range from this I value, but we will fill continuously in the output our resultant array R. So we will start from the I equal to start, and that value should be I less than equal to end, okay, and I plus plus. And inside this, so this R array actually will be filled by the range. So R j equal to I. Okay, and j will be incremented by 1. And this I will be incremented by the step value. So equal to I plus step. Okay, so this is the I value is actually reading the range. So start values, it will start from the start value, and after each step, so I equal to I plus steps we are using inside the loop, and then this is the end condition, so that our I will, this is the last value, this is the I less than equal to end. Each time we are just passing, storing this I value inside the Rj, and we are incrementing this j by 1 in the every time. Okay, so in this manner we are getting this I array, and inside the main function we are creating this array R R. Okay, type of this is array structure. So here output is returned, different we return R not R. Yeah, this is the lane. Okay, so this is actually R is representing only one value, this frame, but we also need to return this length. Okay. Dot wells. One another function we can use, if so, this is struct return type actually. So what we can do, we can directly assign this array like this. So like same struct type array, and res equal to, so in the stack manner. So that means we need two value for the array structure. First is the value pointer, so this is the pointer, and this is the len, two field is required. So inside this, so we can just access the parameter of the structure like dot, by the dot vals equal to, and because we are creating the new array, so we can use this malloc function directly. Like this, and comma, and second parameter is dot len equal to, so we have already calculated this len here. This is now done. Okay, this is value, this malloc size done, and after that res dot vals plus plus. Okay, and return this complete, so return res. Yeah, this is another way. So we have created this structure array and for the returning. So this is array res. Inside this we are maintaining two values. For the first, for the pointer, this vals, and for this we have created one array of the integers, and another variable is len. So we have passed this dot len equal to len. Okay, and after that we have assigned the values in this array res. So res dot value. So res representing the array, that structure, and this vals is actually a pointer of the array, and we are assigning the value inside this. So let's check. I think some conditions are still missing. Let's we will check. So first things we are getting I undeclared. Okay, so where is we are using I? So let's use this int, and j is also not. Error expected or before entering. Where this is missed. One is here. Okay, 2 is passed. So 1357955. But yeah, okay. So negative indexing actually, okay, negative index, that part is not covered. For this case, step value is j static list. Okay, if our step value is negative, then conditions will be changed. Okay, so for this part, actually, so this condition is true for if our that step value is positive. Okay, but if our step is negative, then it will, this condition is not true, because our indexing will be moved to the 0 side if negative value is there. That means we will start from like 7, and again step value is negative -2. So that 7 -2 will become 5, then it will become 3, then it will become 0, like this. Okay, so our that at the time our I value will decrease. So our conditions should be different for this case. So what we can do, we can make one condition here. Okay, ternary operator we can use here. So like step is greater than 0, then we will question mark, and condition should be this. Otherwise, condition should be I is greater than equal to and I is less than equal to and greater than equal to end. Okay. Yeah, this is fine. So this is the terminator, the ternary operator. Ternary operator, what is this? If step value is positive, so that we will use this condition, I is less than equal to end. Otherwise, we will use this condition if step is negative. So negative means we are traversing in the decreasing order. So that means our end should be smaller than to the start value. You can see here. So start value is 10, but end value is 1. Okay, and every time we are stepping by -2. So that means we will start with the 10, then 8, then 6, and we will reach till 1. So this is the reverse indexing. So for this type of case, we will use the second condition, this I is greater than equal to end, because here end is smaller than to the start value, and step value is negative. So every time our I will become less to the previous value. So let's test this. Okay, now this is fine. Yeah, it is working for the negative indexing also. So this is the solution for the PPA5. Okay, so first thing we are calculating the length, then we are creating a res return value, that is the type of that value is array, and that contains two value. First is the pointer, and for inside the pointer we are just allocating the memory block of the len size, and for the len value we are just assigning the len value. So you can see the structure, so that both values should be returned by the function. Because of that, function return is array. And for this, after that creating this, we are simply filling our memory block res.vals. So that will be filled. This ternary operator we are using for the both conditions satisfy step, negative step value and positive step value. And after that we will return this array. Okay, array structure res. So this is last PPA of week 5. Any query in this? Or any query in the theory assignment, PP practice theory assignment? Anyone? So for theory assignments, let's quickly check. Okay. So which of the following function is are used for the dynamic memory allocation in C language? So on the last Tuesday we have discussed actually malloc, free, calloc, realloc. So here memory allocation we are asking. Okay, so memory allocation, which function actually we use? So malloc we also used, calloc is also for the memory allocation, realloc is also for the memory allocation for the resize, to the resize. Okay, and but free is actually to just deallocate. So here our answer should be first option, and this calloc and realloc. Okay, this is also comes, free is also comes in the category of the dynamic memory allocation, but this is not for the allocation, this is for the deallocation. Second, which of the following statement is a true regarding dynamic allocation in C language? Both malloc and calloc function are used for the allocating memory at runtimes. Yeah, this is correct, but it is asking, okay, this which of the following statement is a true regarding dynamic allocation? Okay, so this is true. The malloc function also initialize the allocated memory chunks to 0. Yeah, this is not correct because initialized by the 0 is happened by the calloc function, not the malloc function. The free function is used to release the specified block of the memory. Yeah, this is correct. Okay, so this two statements are correct in this. What is the purpose of the free function in C dynamic memory allocation? So this is the release allocate memory. Okay, release. Which among the following statement is are true about dynamic memory allocation in C? Memory allocated. Okay, the two dynamic memory allocation in C. Okay. Memory allocated dynamically cannot be released until the program ends. So this is not true because we can release by the free function. Memory allocated dynamically should be released using free function to prevent memory leaks. Yeah, this is correct because if we are not using the allocated memory, so we should free that memory. Otherwise, if suppose if someone access that memory, that may be the security issue. So yeah, this is correct. Dynamic memory allocation in C is performed at compile time. So no, this is not correct. That memory allocation is happened on the runtime. So this is not correct. Dynamic memory allocation provide flexibility in managing memory during program execution. Yeah, this is correct. At the time of runtime or execution, we can allocate some memory. So that is B, and D is the correct for this. In which scenario using dynamic memory allocation would be particularly advantageous? Okay, when the memory requirements are fixed. No, dynamic memory is actually good if we don't know the requirement size initially. Okay, so that type of data structure actually need this dynamic memory allocation. So first option is not correct. When the program has a limited memory footprint, this is also not correct. When dealing with the data structure of varying size and uncertain quantities, yeah, this is correct. Okay, we don't know what is the requirement size. When the program utilize only stack based memory, so this is also not true. What happens if the realloc function fails to resize the allocated memory block? Okay, so realloc actually allocate memory. Suppose at the first time we allocate 5 integer storage, but later we need 5 more. So that we use at the time we use the realloc function. So actually realloc function add 5 integer elements more. Okay, but it will not affect the previous data, previous things. So if it fails, then that means our previous original data will so it leaves the original memory block intact. So the second option is actually correct. It throw a compile time error. No, this is not correct. It automatically free the memory block. No, it shift the allocated memory to the stack. This is also not. Okay, it will not allocate the memory, but the previous data will remain the same allocation. How many elements are there in the 2D array int matrix 3 and 4? So rows are 3 and columns are 4. So 3 into 4, 12 elements we have. In a row measure representation of 2D array ARR with base address B, where the each element occupy W bytes, what is the memory address of the ARRI, J if a array size number of rows are R and number of columns are C? Yeah, this is important question. So some numerical formula questions may also be asked for this type of question. So this is formula basically. So number of rows is R and number of rows is column. So this is R by C array we have. So suppose R equal to 3 and C column equal to 4. So that means 3 row and 4 columns. So and row measure representation. So our memory allocation will be happen like this. So first, like this is the memory block. Let's 3 4. So lower part is not there. Okay, 0 1 2, this is representing 0 1 2 3. So this is R and this is C side. Okay, so suppose row measure implementation, if the this first block address is like 1002 and all elements are integer, so the next elements will come at address like 1006, next will come at 1010 and 1014, and after that next row and first element will come at 1018, like this. So addressing will happen in this manner. So our allocation are continuous space, but the first row will traverse and then second row will traverse, then third row will traverse, like this. Okay, so if our elements are like this 1 2 3 4 5 6 7 8 9 10 11 12. Okay, if these are the elements for the allocation of this array ARR, so this will be initialized by like this. So 1 2 3 4. So the first 4 elements will be assigned for the first row, then second 4 elements will be assigned to the second row, then third 4 element will be assigned to the third row. So this is called as a row measure representation. So row wise we are storing the data in our memory. So like 5 6 7 8 9 10 and 12, like this. Okay, so here what is given, base address is B. So first thing, array size is R by C. Okay, this is the total size, but asking that what is the size of I comma J. So I and J is representing any middle indexing for this any element. So how we can directly calculate the address for this? So base address is given. So base address means what is the address of this first element. Okay, so this is 1002 like. Okay, each element occupy 4 bytes. So here we are taking the integer case, so integer takes 4 bytes. So it is here given is w bytes. So that means this is representing this addition. So you can see we are adding 4 every time. W is representing that things. What is the address of this I comma j? Okay, so in this case, suppose if we ask like ARR, what is the address of 1 2? Okay, 1 2. So how we can do? So 10002 is the base address plus. So for this 1 2, how many rows are there actually? So how many rows we have completely traversed before? So that means that we can easily calculate by this I value. So this is representing 1 we have already done. If this is 1, that means we have completed one previous, that is actually representing by 0 index. So that value we can directly take. So we will multiply by the each element size w, but and that is number of rows, how many number of rows we have completed. So that we will write like this. So I, okay, so that means 4 into I plus okay, so that is 0, that is I representing, or into I, okay, 1 2 3 4 columns. Okay, that is I into 4 actually. Okay, I into, so how many columns we have in the each row? So that is representing by the C. So I into C. So that means 1 into C we have already traversed in the previous row. So this is representing this. And we are asking the address of this part, this value. So that means we need to add some address calculation for the remaining part for the current row. Okay, so I plus C and plus, so that is representing by the J value, this value, okay, 2. So that means if we calculate the address for previous value, so that means J. Now you can simply calculate 1002 and plus 4 is representing the each element size, I is representing by 1 and number of columns are 4, plus J value is representing by 2. So 1 plus 4 into 2, 6 into 4 and 24. Okay, so 1002 plus 24, it will become 1026. So you will get the same address. Okay, so 10218, then plus 4 1022, and then 1026. So the starting address of this block is represented by 1026. So we can calculate the address in this address. This is B plus W and I into columns. If this is implemented in the row measure, then I into C, okay, plus J. This is the formula. So this is representing by like this, B plus W into R in that C into I plus J. Yeah, this option B. The next is just opposite, column measure. So for column measure, our elements will be stored in the column form, like same array, like 1 2 3 4 5 6 7 8 9 10 11 12 0 1 2 0 1 2 3 R and C. But this time our elements is will stored column wise. So 1 2 3, then second column 4 5 6, then 7 8 9 7 8 9, then 10 11 12, in this manner. Okay, so addressing will also be happen in the similar manner. So for this type of our calculation will become different. So for calculation, now the formula will become change of the reverse of the previous. So B plus W into R into J plus I. So this last option will become correct for the second ninth problem. Okay, so just solve some calculation using this formula and check check how this is working. 9th. So yeah, what is the size? How much of memory will be allocated for this pointer PTR? Okay, so integer takes 4 bytes. So 4 into 4, 16. So 16 bytes will be allocated to the PTR. So option this is correct. And here this bits representation is given. So 16 into 8. So that is 128 bits. Okay, both are same. Okay. So in this program, what should be the value of the question mark so that the program display 8 as the output? So here this is the allocation. So by default this okay, so this is given as a row wise. So the first bracket is representing as a 0th row, and second bracket is representing the first row, and last bracket is second row. So that means 2 index, and we need to find out the 8 output. Okay, so 8 is coming in the first row, okay, first index row, and inside the row indexing of the column is 0 1 2. So 8 is coming at the second index column. Okay, means first index row and second index column. So you can see last option is we can directly check. This is true, one index row and second index column. But in the terms of pointer, so PTR1. Okay, so PTR is representing the pointer of this. Okay. PTR3. Interstic PTR3 equal to ARR. PTR3 to this. With that operation, I have to check. Let's check this. Yes. Into 3 3. Okay, so ARR 3 3 equal to first. Okay. Okay, that PTR. You have to check. So PTR3, and this is 147,258. 147. 258 and last 369. 36. Stick PTR. So this is. Okay, so we are printing this. Asterisk PTR1 plus 2 PTR1. One PTR0. Okay, and this is 3. And options are 3. Okay, so this pointer is declared, but there's no meaning for the second line. So for 8, actually, to print for this 8, how we can print? So that is actually PTR0 is representing to the 0th row, and after that we can add the element 0. So that is representing the address of the 0th row first element. PTR1 is representing the address of the second row first element. After that we can add some value. So that value we can add like this. So PTR1, this PTR1 is representing to the this row, and we need to print this element 8. So we have to add plus 2 value. Okay, so that 4 we are getting. So this is happening inside the pointer basically. So we will do like this. Still not correct. It. So that means this value is representing the address of the first element in the second row. Okay, and after that we are using arithmetic, pointer arithmetic. We are using 2, that means 2 integer address. So that means 8 byte we are adding in this address, and then we are getting the address of the this last element. And after that we are dereferencing that location using this asterisk sign. So that is printing this 8 element. So option B is correct for this, and not B, A. Okay, so if you want to print any element from the first row, you have to write this PTR0 and then plus 0, then plus 1, then plus 2, like this, to traverse all the elements. So this is by the pointer field. So A and D is the answer for this. Yeah, for this code actually you have to use, you can use this Python tutor. And so answer is not correct for this, because the more than 4 answer is correct for this question, but all are not coming in this answer. So we will just update this from the backend. But you can check which nodes actually contain some address during the execution of this program. So when you run this on the Python tutor, so you can see step-by-step execution of this code. Scroll down, see this error. Where is error? Error is coming. Okay, int a equal to 0, line 2, equal syntax. Why this is int a equal to 0? Code is looking fine. Okay, we will discuss this later. So let's complete the another part. Okay, so remaining questions are actually you can just try to write the code and check which are the alternate code we can write, fill to complete this code. So like this, to question number 14, what code is required at this code block 1 part to print this output 1, 2, 3, 4, 5. Okay, so just check how we can get this code. So here n equal to 6, and inside this loop I we are starting from n value and we are decrementing each time. Okay, so and q, okay, so we are using q here. So that q we need to do what way we can use this q. So you have to check this code, and so inside the code option, what we are doing actually, so we are creating a pointer p, and that is integer elements and malloc size of int into n. So this is fine, and int q is another pointer, that is p plus n. Okay, that memory allocation we are doing with the dynamic memory. So and output is 1 2 3 4 5, and we are printing the elements like this: I equal to 0, I is less than 0, I plus plus, print I 0 1 2 3. So q minus I equal to that n indexing, we are using this I. Okay, and we are printing simply. So negative indexing means you're starting n, suppose n equal to 6, so minus 6 will become 6. Okay. Okay. Minus 5 equal to 5. Okay, this is happening negative indexing. Fine. Memory allocation. Q is equal to p plus n pq plus. Q is equal to p minus n p plus n. Option A is looking correct for this. So what happening here? So we are allocating memory in the P, and we are also pointing a pointer Q, and that is actually point starting from the last address. Okay, so we are allocating this memory block for the n elements. So by this Q equal to P plus n, that means we are reaching at the last address of the for the last element inside the Q, and after that we are filling this by this loop for in this value. So that is minus 1, that will represent by the last address of the Q, and at that address we will fill this value by 6. So suppose this n equal to 6, so this will fill by the q minus 6 equal to 6. So last element will become 6. After that it will increment 1. So q minus 5 will become 5. So elements are storing in from the reverse order. So from last block to the first block. Okay, so 6 5 4 3 2 1 like this. And after that we are printing these elements by this p index. So you can see our I loop is running from n to till 1. So in same manner, our data will also be print in the output, because this time we are printing the element from the first location. So this is by the p block, okay, p pointer. So p0, p1, p2 like this. So in this manner, we will get the reverse output from the starting point 1, 2, 3, 4, 5. So option A is looking correct for this. So this is following the all correct syntax. In the second block, because we are not assigning the total size, only size of int, only one integer element size we are allocating. So this is not correct. And say, yeah, this indexing is also not correct. So q equal to p minus n. So this will move to the address which is not allocated for us. So this is also not correct. C, and same for the D. We are getting to the address which are actually not allocated for us. So option A is correct for this. So this is also a code based question. So just check which code. Yeah, here one code is given. Just check which is the equivalent code for this create array. So the create array function is already given in the code itself, but can we replace this code by the another array? So inside this first, you can see we are creating a int asterisk an array of n, and int asterisk b of int n malloc size into the n. Okay, so just try this code on the editor and check how the code is working. So this is just for the execution purpose problems. But yeah, this problem is actually not correct configured 12 problem. So we will also check and we will update this soon. So if you have any doubt, you can also ask in the next. Okay. So any query remaining the week 9? From week 10, we will start from the Friday.
Okay, sir.
Okay. Thanks. Okay, then thanks. Thanks everyone.
Thank
Thank you,
you.
sir.